Good day everybody and welcome back to the channel. Um, I'm back in the lab now. I've had a few things to get done this week, but I am back around now. So I've got to start laying out this for my amplifier, but before I discuss that, I just want to go over a few things. I've actually written some notes down because there's no way I was going to remember it all. But okay, first thing, I just want to touch on this very quickly. I know I've discussed it more than long enough in previous videos, but I did more testing on that power transformer. I worked out how Soundtech made it work. So there is a way of wiring two primaries, one from each transformer in parallel and then the two in series, that produces 43 volts on the secondary for the amp that doesn't sag, and it also produces at 600 milliamps 18 volts after rectification on the fan winding. So that's obviously how they pulled it off. 600 milliamps is way more than what's needed. It makes sense too because the amp was only rated for 165 watts into 8 ohms, so they didn't need rail voltage that high. So 55 volts after rectification is plenty enough for that. So that explains that. Now I've had a look at the transformer, and I was going to rewind it, but I've only got a 3.5mm gap here in the middle, so I'm not going to be able to fit much more copper in there. So if I want to say wrap the primary with thicker gauge wire, or add more turns to the secondary with thicker gauge wire, something like that, it's not doable. So what I'm going to do for now is run them boosted, and then in a month or something like that, I'll get new transformers or custom wind them or get them custom wound, whatever it may be. In saying that, I have ordered a massive beautiful case to build this or these amplifiers in. I've decided one case because I found one that was big enough. The thing is, if the case is big enough to fit a boost transformer in there as well, I might even just leave it. It really doesn't bother me. It's only going to bother me if it's out of the case and I have an extra box somewhere. I just don't want that. But anyway, that's all I've got to say on that. I'll leave that over there. Okay, back to this. So, I'll just quickly go over what I want to achieve and what I've picked first. So I've actually pushed my preamp design that it already works. I wanted to improve on it, add a current source and a few things to it. I think I'll leave that for now. I've had a look at a few different amplifier designs, particularly the Doug Self's Blameless B amp, the Hummingbird amplifier, an old Yamaha design, a few PA amplifiers, and I've basically decided that I'm going to go with the input stage that's in the Blameless amp, Hummingbird amp. Let's see. Actually, there's another amp that I found that's similar to... Oh, sorry, that's on my phone. I'll have to pause the video and transfer some stuff off my phone onto my computer to show you guys. That's alright. But anyway, I've chosen to basically go with that input section, but I'm doing things a little bit differently. So, my current sources... Well, for starters, the VAS is not going to have a current source that's mirrored off of the input pair's current source. I don't believe in mirroring the references, mirroring the current source's references, sharing references, you know what I'm trying to say. Secondly, I've chosen an LED, and the reason for this is because a red LED is 0.4 nanovolts per root in hertz. The noise floor of it. It's as quiet as a 10 ohm carbon resistor. You're not going to beat that. Also, if you do the maths on it, noise per volt of reference, this comes out quieter than using transistors, reference diodes, Zenas, blah, 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 blah. So that's why I've chosen LEDs. I've got two current sources here, At the moment, they're both set for 2 milliamps, but 2 milliamps is decided upon for this one, for the input section. 2 milliamps is just temporary in here for the VAS. Alright, now I've got a few things I want to talk about quickly before I go back to what I'm doing with this, what else I'm doing different. I mean, not too much, to be honest. I'm thinking about adding a Wilson current mirror to the bottom of this, but I haven't decided upon that yet. I probably will. Also, the resistor values in the tail and in the collectors I'm going to play around with, and they will be balanced out, you know, once it's in situ in the amp and loaded down in the final situation. Those will be tweaked. You know, so they won't just be exact 68 ohm, 100 ohm, whatever. So what else? Tweaking your resistors. Oh yeah, the input. Okay, a lot of people probably give me shit for this, but I don't really care. I'm a bass head, and I like the. I'll tell you the two main reasons why, or three reasons actually. I like to have a 15k input. I just find it's a good margin over, you know, lower input impedance, less noise, better loading on the input. You know, in terms of getting noise off the cable and picking noise up as an antenna, I mean. At the same time, you want a high impedance on a amplifier's front end. So I find 15k is alright, you know. I see people going anywhere from 10 to 22 to 120k, all different values, but usually in the 10 to 22k ballpark. So I choose 15. That's just me, personally. Now that can vary with different amplifier topologies, but with a standard differential input pair, that's the way I roll there. What else do I have to say on this? The cap I always choose. Okay, so it depends. If it's a bass amplifier or I might be running subs off of it, I always will go 100 microfarads. I don't really care. That seems oversized to a lot of people. The cutoff frequency, if you use a 100 microfarad cap with a 15k input resistance to ground, is 0.1 or 0.16 or something like that hertz. Now, the reason I've gone down to 0.1 instead of 1, even though 1's technically the lowest frequency that you're going to feel running subs that are running subsonic frequencies, you know, say the end of a thunderclap or something like that, where the subcone really wants to just do the slowest kick, you know. Well, the thing is, how do I explain this? Where your cutoff frequency is where you get a 45-degree phase shift. So if I want it to be absolutely perfect down to whatever frequency I want to hear, I need to cut off an order of magnitude lower than that, if that makes sense. Again, yes, this is totally overkill. You know, if you're just going to the go comment section to tell me it's overkill, I know. Let me say this: if I'm building an amp that's just for speakers and the subs are going to be run off separate amps, and this amp's definitely not going to run subs, just speakers or full range speakers, I'll usually go down to 1 hertz, and then the capacitor ends up being around 10 microfarads. And when I do that, what I do is I put a couple of 4.7 microfarad, like MKS4 high quality film caps back to back, and in parallel, I mean, sorry, they're not polarized. And that's what I do. For something like this where I'm using 100 microfarads, I don't mind the electrolytic. Look, people have done research on this, and the distortion caused by an electrolytic cap in the input it's next to nothing. The other thing is, I'm pretty sure the bigger you go in value in cap, the more that effect would be nulled out, just due to the capacitor being a better capacitor, having lower ESR, just a lot of more technical stuff. But I could be wrong there. That's just a guess. But anyway, enough on input capacitors. So 15k and 100 mic for this amp. Honestly, I might end up doing 10 mic. I haven't decided upon that. It's going to be 100 or 10. It's not going to be smaller than 10 mic. I can tell you that. I'm thinking about actually putting two 4.7 mic MKS4 film caps back to back, but at the same time I'm also thinking about changing the cap that I put across these two resistors here between the bases of these pre-drivers and the cap that's across the resistors on the bases of the output devices. Drivers, and the output's not pre-drivers, to a higher quality cap too. I did a little bit of research into this, and the reason I avoided using, I'll just show you what I'm talking about. There you go, I can't find the particular cap. I'm going to have to come back and pause, I'm sorry. Oh no, I found it. Okay, so I'm talking about stuff like this, MKS4s. Oh, actually, that's not MKS4. I grabbed the wrong cap, sorry. Alright, I thought I had the value I was looking for, but I don't. I've got 2.2 microfarad MKS4s and 10 mic MKS4s, but I don't have 4.7s. Anyway, I'm thinking about using some of them. If I don't, I think I'll save the good parts for the next build, because after I'm finished building these amps, I'm going to build a more higher performance amplifier with more quality parts and more powerful, higher quality output devices, more higher quality components, all that sort of stuff. So I think I'll save that for down the track, and we'll just stick with 10 or 100 mic electrolytic for this one and the 15k input. Anyway, alright, so now I want to talk about some other things that I'm going to do on this that's not included in the designs that I've mentioned. Other than, getting the resistor values exactly right and having better voltage references for the current sources and having separate current sources, and I'm going to add a Wilson current mirror here too in the tail. So the other thing that I'm going to do is I'm going to match the absolute crap out of the transistors that are in current mirrors, input pairs, all that sort of stuff. When I say match them, I'll show you my technique, or you already know my technique for matching transistors. We've gone over that in videos where I've shown how just, picking them up will change your VP and all that sort of stuff. And I've shown how when they're on top of a heatsink or mounted to a heatsink is the best way of doing it, because it holds them all at the same temperature. Although you have to be quick, because as the room temperature changes, all transistors change quickly. But anyway, my point is, these are going to be at least mounted to an aluminium block or something and tested very quickly, because I want them within less than a millivolts. I want them accurate as possible. The other thing I'm going to do is things that should be thermally coupled, and yes, I'm aware that you can buy thermally coupled transistors, but I have tons of these and more on the way that I ordered. I'm not talking just about MPSA 42s and 92s, lots of different transistors. I'm going to glue them together and thermally couple them. And what I mean by that is basically sand the front down just a little bit, not so much to get the die closer together, but to rough it up so that the glue never lets go. And then just glue them together like so. So thermal coupling. Also, I want transistors that have got high gain, low cob, and a good early effect, which I understand it's hard to find all these things in the one package, especially at higher voltages. So we'll see what I can find. Again, I'm not too worried about this particular amplifier. I'm trying to do a good job on it out of what I've got, more than trying to make a really, really good amp. So a lot of this I'm saying is more just my design philosophy. Now, the driver boards, a lot's going on here. So I forgot to add base resistors. My amp needs 100 ohm base resistors on the basis of these transistors. I forgot them. So what I've done is I've moved the diodes over from where they were, and I've put 100 ohm carbon film base resistors there and stood the diode up on its end, so I can solder a wire to the end of the diode, put some heat shrink over it, and run that wire to the diode string that's on top of the heat sinks. Not perfect, but it works. The other thing, I've decided to do away with the resistors and pots and go with a VAS, and a VAS that has, current sources, and current source VAS. So those will get removed as well. I haven't decided how I'm going to do this yet. I might get real cheeky and just get my Dremel and cut up these tracks that won't be used anymore when I remove these components, and that might give me enough sort of like proto board, if you get what I mean, strip board, to lay out the VAS on each side. Who knows? It would be good if I could do that, because then I could keep my driver board with, everything that goes on it on one board and the input stuff on another board. I'm not worried about things getting moved around and it being a bit dodgy, bodgy, whatever you want to call it, because like I said when I started building these, the reason I've made a whole load of little boards is because I intend on pulling them in and out, changing them around, maybe even making up whole new boards with totally different topology of circuits. So I'm not really bothered. This was the whole goal of it, and I can tell you now, as soon as we get this up and running, we're going to be taking tests and then just doing modification after test after modification after test. So these boards are going to get raped, literally. I mean, don't be surprised how many cuts and jumper wires and changes and stuff happen to these boards over the next couple of weeks. So I'm not really worried about it with that in perspective. Amazingly, that's all I've got to say. So now I'll get on with what I'm doing here. So at the moment, I've just been working out current source values, emitter degeneration resistors, collector resistors. I'm still working out my collector resistors. I'm just loading my input pair with a 100k resistor to ground, just so I can do some rudimentary stuff. Obviously, it's going to completely change in terms of linearity and load when it's hooked up to a test output stage, and then it's going to change again when it's actually in the actual amplifier. That's why I'm going to be leaving provisions to make changes down the track for certain things like, emitter resistors, and I mean, you can change them anyway, they're resistors, but you know what I'm saying. So I've just sorted those out, sorted that out. Now what I'm starting to sort out is the VAS. So I was using this just for some testing, but now I need to do voltage amplification. I now need to put a driver and a pre-driver onto this stage, mimicking my output stage, so that I can hook this back up to that and not have it pull down the entire signal because it's gain limited because of the input impedance of this circuit being way too low. So that's what I've got here. I've got a D88, excuse me. I've got a D882 and a B772 transistor and another A42, A92 pair there, just for mocking up a little output stage. So I'm gonna make those changes now. I can give you a quick look at my work area. You'll probably have a good laugh at this, but this is how I work, and I find this is the easiest way for me to do it. Is I just grab all the boxes with the components in them that I'm going to work with and lay them on the bench, and then I can just sit there, just Anyway, so I've got my board set up here. One thing I am doing, although, impedances and linearity and gain and all other things are different to my actual amplifier in this circuit, one thing I am doing is I'm designing it with the same voltage. So the rails here are what my amp is. I mean, it might be 6 volts shy, but there's 120 volts there. It's limited at like 12, 15 milliamps, like not much. But I am designing with high voltage. I'm comfortable working with it, and it just saves me the headache of having to do lots of maths because I've got to change resistor values and stuff like that for voltage reasons. Anyway, so the way I'm getting that over here is long leads. We've got 30 volts in series, and then I've got another 2 chunky ass leads coming over here, and we're doing the same thing over here. So that's my 120. I've got the signal generator over here. Focus. It focuses and then I'm shaky. There you go. And there's our output. I can make that perfect if you want. The reason it's not perfect is because there's no trimming resistor in here. These are both the same value. Anyway, yes, so that's what's going on at the moment. I'm going to get this VAS sorted out now, and then I'll start drawing a circuit diagram so I can show you what's going on, because that's just something I've been doing lately. I find it's easy to explain stuff to people, and it's probably better for you guys than staring at a mess of stuff on the breadboard. I just wanted to show you guys this. Guess what arrived? RXLG 500 watt, 4 ohms. And I've got to say, inductance wise, I'm not too impressed. They could be better. Let's bring them over here and have a look. Resistance wise, I'm very impressed in terms of the accuracy. They are ridiculously accurate. Look, these aren't anything special. I just got a Chinese manufacturer to make them up. They make resistors. There's heaps of sellers on AliExpress and places like that, and some of them will do custom stuff with the factory if you ask them to. That's how I got these made. I did go with a seller that I've had good luck with, and like, they were custom made, but they're not anything ridiculous high quality or anything like that. But I'll just show you. Well, you know what, I'll get the LCR meter over here. Why would I bother bringing two meters? So 3.866. I'll just grab one more. They were sold as 5% tolerance. So, I mean, this is good news. Yep, 3.82. They're all about the same, basically, so I'm not going to sit here and test them all. Actually, I'll leave one here because that's what I was going to do. Oops, got to remember that's powered up. Inductance. So, let's see something. Alright, so at 1 kilohertz, 4.2 microhenries. 10k it's the same, and 100k it's the same. However, down at 100 hertz it jumps up to 6, 8, 9 I've seen. It's not too bad. If you think I'm being fussy, I'm not. go do your research first. Low induction resistors can be way lower than that. And I did specifically ask for low induction resistors, but I have absolutely no complaints because they cost literally nothing. I mean, I can't remember exactly what they were. They were $22 each if you bought them not customized. I paid a little bit more for custom ones, but not much more. And shipping was honestly ridiculous. But the resistors themselves, they're not that expensive. So, you know, I'm more than happy with what I've got for this. Now, these aren't solid fill with ceramic. These are silicon sand filled, but it is advertised as that and sold as that. It's not claimed that they're solid. And honestly, if you shake it around, you can hear a little bit moving, but it doesn't sound like it's, you know, running around in there and there's a lot of space. It honestly just sounds like a bit of sand is just moving around where the resistors formed. Yeah, they could have done a better job packing it, but I've already run 250 watt load into them. Actually, that's something else I wanted to show you guys, because I wasn't just impressed with the thermals on them. I mean, I ran 250 watt load, 250 watts into them for quite some time, and they got hot, and they, you know, they didn't change in resistance or anything like that. Just give me a minute. I've got something to show you. All right. So I've just turned that on, and that's 250 watts going into it. And as you can see, the current doesn't go up or down. The voltage isn't going up or down. It is maintaining its resistance. And I've got my power supply right up at the top of its voltage and current limit. So the voltage can't go up anymore to maintain current for the constant current, because it's up as high as it goes. So we would see the current falling if the resistance of this was increasing. I hope that makes sense. And I ran this for ages and it got bloody hot, 250 watts hot, and it just stayed exactly where it was. So very good resistor. I'm very impressed for the price. I mean, the resistance doesn't change under a lot of heat, so that's definitely a stable resistor element in there. Yeah. Anyway, video coming soon. Basically, I've got to build a frame. I've shown you guys this before. I've got this box and all these banana jacks, and I want to build a frame that houses these, and they will be wired into this box full of banana jacks and jumpers with a couple of BNC outputs, so that I can put jumpers between banana jacks and make different ohm combinations, and I'll have banana jacks for the inputs, BNCs for the outputs. So that project's coming up soon. Alright, this is a little bit interesting, but at the same time not too interesting, because it's kind of to be expected. So I was having problems getting the bias right, and I was just going to take the diodes out and just use a couple of resistors in there as a bias spreader to make it more simple, but I still wasn't having much luck. So I went back with diodes. Not that that makes much of a difference, it's just easier to count segments of voltage. Anyway, I've disconnected the PNP and NPN drive because, and gone back to using resistors to bias it just now, because I found that this is acting a lot different to the amp that I built a few years ago. I'm not surprised because I've got completely different devices, but the thing is, when I built that amp years ago, as I've mentioned plenty of times, I had problems with cross distortion, and the other thing I wanted to do was reduce resistor values in certain places in the amp that were too high, but the transistors that I had in there and the gain that they had and everything, it was the way it worked out. Now, I'm not too sure if the problem I'm having, I've got a funny feeling it's because I don't have large output device. You know what? I'm going to go get some large output devices, because what I'm finding is I've got a 220 ohm resistor here, which is across the bases of the final drive transistors. And here, I've got 2.2K across the bases of the drivers. Now, sorry, output devices. I meant before when I said drive, final drive, you know what I mean. Anyway, drivers have got 2.2k across them. Now, my original schematic only had 820 ohms across it, which seems more reasonable, but the thing is, I'm going to have to work out, obviously, you know, the values when I go to fit all this in these amps. So I think what I'm going to do is I'm going to change a few things. So the two 430 ohm resistors in series forming that roughly 820, or 860 in this case, but anyway, I'm going to leave them there. And the 200 ohms I've got across the output devices bases I'm going to leave there. But the resistors in the middle of the diode string where the pot is, or pots, I'm going to change them. Because as you can see here, I've got 6 diodes here, and they're normal, they're just 1N40007s. I could use, you know, small diodes or diodes of a different junction, but I'm trying to copy what I've already got so it's easier to work it out. And those BY229 diodes, I would imagine would have a similar forward voltage drop as these at a low current. So I don't have any resistors in between those diodes, and this is biased on. So yeah, I've got a little bit of working out to do, but anyway, it's alright because I'm only building this just to play around with this circuit down here. I'm not trying to get the final component values or anything like that, because it's impossible to do that anyway without it being driving the actual amp that it's going in. The linearity, gain, everything's going to change when you put a front end and VAS in with another output stage and driver. So you know, it's fine for what I'm doing, but it's just something I've got to bear in mind. Anyway, just thought I'd point that out. So I think what I'll do is I'll pause the video quickly. I'll just finish doing what I'm doing here, and then we'll start putting a signal through it and have a look and see what we've got in terms of gain. At the moment, just with this single stage at the front, not going through this, I've got 60 volts of peak to peak, so about 22 volts RMS of swing without clipping. So I want to make up another 15 volts with the VAS. So I'll finish setting that up, and then I'll give you guys a look at it, and then I'll draw out a schematic and give you a look at that, and we'll take it from there. Oh yeah, one other thing I wanted to mention. I'm having a hard time deciding VAS current. At the moment I've still got 2 milliamps here, but I'm a little bit worried about this, and this brings something back to mind too. My original amp that was resistor biased had about 2 milliamps across, well, not exactly across the diode string, but being sourced by these resistors. Now, the thing is, I had bigger transistors in there. I had, what are they called? TO92 something. They're about that big. Actually, I'll just go get some to show you. Alright, I'm just going to drop a TO92 device in with these, just so you can see. So that's what I was using. Now, I've got some that I've ordered that are going to arrive here in a week or two, so I mean, I can put them back in, I just need to match them. But what I'm trying to toss up now is how much VAS current do I need? Because I want, you know, a couple milliamps going through the diode string, but I don't know if that's going to be possible to get a couple of milliamps flowing through the diode string without too much current going through the base, getting amplified, coming out the emitter, and wanting to drive the output too hard into bias. And the only way to solve that is to decrease the values of these resistors. So if I did that, then I'd be putting a huge load on these two transistors. You see why that's a problem. I think that's why I had bigger transistors in the original amp. So that's what I'm trying to work out now. I've got a little bit of working out to do. I'll do that off camera, come back, show you what I've worked out, and like I said, draw a schematic and we'll go over it. Oh my God, do I feel like an idiot after what I just said. Screw that. There's not going to be a problem getting 2 milliamps at least across the diode string because I've got an incredible amount of gain here in the transistors. So yeah, I can do that. I don't know what I was thinking. I've already got 1.7 milliamps going through that. Anyway, and I still need to increase bias voltage and a few other things. I'm not done yet, so I think this is going to work out. But anyway, I don't want to confuse people, so I thought I'd just correct that. If it turns out that I was right, I will recorrect myself again. Alright, I've worked that out. It's actually not going to be a problem at all. It's just because I haven't played with an amplifier for a few years. I just forgotten what is normal, basically speaking, without going into detail. But the resistances that I was worried about are actually quite normal. And this now I've got a 1.8k resistor in here, and I'm nowhere near the bias current I would be running with output devices on a heatsink. So yeah, this is all mathing out. It's going to work fine. I've just got one problem that I have somehow created. I don't know how, but I've lost my gain. That stage still has it, but when I put it in the loop, it disappears. So I've got to work out what I've done there. Then what I'm going to start working on is linearity. Now, I'm thinking about putting a pot across each one of these 68 ohm tail resistors, but to be honest, you can perfectly null out offset voltage by doing that, but thermals, ambient temperature, all that sort of stuff can cause it to end up not where you set it. So I'm thinking about maybe making a slightly more complicated input stage. I haven't decided yet. I'm sure there's something you can do with another current mirror or something like that that makes sure that it's perfectly balanced. I'm going to have to do a bit of research on that because it's gone out of my mind. It's been like 3 years since I built an amp. So yeah, I don't think that's the Wilson current mirror that I'm talking about. That's just going to provide a more stable tail current. That's a current source. No, it's a mirror. Yeah. But the thing I'm talking about is a current mirror that goes between the collector legs, if I remember correctly. I could be wrong. But yeah, I'll let you know when I work that out and when I get my gain back, and we'll continue. I'm going to start drawing up a schematic soon. I just need to finish solving these two things and then I'll give you a look at what I've come up with. But I'm starting to get close to final resistor values and all that sort of thing, other than the things that are going to have to get tweaked when this gets made up on PCB and added to the actual amplifier that it's going to be paired with. Alright, so I did a little bit of research, and it turns out I can actually do a 4 transistor Wilson current mirror, which is something else I haven't looked at for quite a few years. But as soon as I looked at a picture of it, I recognized it straight away. So that's all good. I'm going to have a go at setting that up and see how it behaves, and I'll go from there. But I am quite close to drawing this out on paper. I still have to solve my gain problem, but that's only when I connect the output to this. So it's not going to make a difference whether I have a 4 transistor current mirror or 2 transistor current mirror for that problem. So I'm going to start on this and then I will move on to that. Anyway, I'll draw the whole thing on paper because it's getting a little bit complicated and it's not going to make sense just looking at the breadboard and me explaining it to you. So yeah. Anyway, I'll get this set up and I'll be back soon. Alright, I'll just hold the camera down here for a minute to get in a little bit closer. I've put the Wilson current mirror in. It's just loaded down with a 100k resistor and feedback side tied to ground for the moment. And yeah, it's working a lot better. I haven't trimmed either of these two resistors yet, and that is quite good. I've only got 58 volts peak to peak as opposed to 60 volts peak to peak that I had before, but I'm sure that there's a reason for that. And you know what, if there isn't and it's just junction loss or something like that, I'm really not bothered about it. I'll make up for that with I'll make up for that in the next gain stage. I mean, I only need another 13, 14 volts, to be honest, so it's not too hard to gain 13, 14 volts. Alright, what I'm going to do now, well, I guess I should finish troubleshooting and work out why I've lost gain when I hook my output stage up. Once I've done that, I'll come back and make a schematic. It's getting late and I need to go to sleep, so I'll see how much more I can get done. Alright, I'm not too sure about the Wilson current mirror, so it seems I'm going to need to add some extra circuitry in between it and the Darlington that drives the VAS. The reason for that, it creates a really nice linear signal compared to not having it, but when I hook it up, I end up with about, I think it was an extra volt or something, maybe more, offset on the output. Now, the fix for that's probably to make some more circuitry to rectify that problem, which is what I was talking about in between that and the Darlington that drives the VAS. But then you're just adding even more components, and I did a little bit of research on this, and some people have tried doing this and noticed very slightly more THD increase. So I want to still try it. If I can get it to work easy enough and it's not, an absolute mission, adding a whole load of extra components and trying to balance it out and this and that, then I'm going to do it. If not, then I'll go back to the way it was. What else have I got to say? Not much. I've drawn a schematic so I can show you what we're working with. So what I've done is, let me just grab my pencil, if I can find it, there it is. So this is the A42 base and A92 base MPSA on my driver board. That's the resistor 4007, 1N4007 and 100 nanofarad cap, 4.7 microelectrolytic, and the diode string, fixed resistor, variable resistor. Actually, just a moment. Those values are not decided either. So these values will probably get tweaked very slightly. So what I've done is anything that's got a circle around it means that there is a value there that I'm using at the moment, but it will get tweaked most likely. And things that just have an asterisk and no value at all are things that I have not decided upon yet. All the transistors at the moment, I've got MPSA 42s and MPSA 92s in there, but that is not how it's going to be the finished product. On that note, the ones that I had in this drawer, I have a total of one left, and I have already resorted to board pulls. So there's already one completely unmatched board pull in this circuit, so that's not good. Really not good. So in the next week or two, I've got a pile of small signal transistors, basically all TO92, a few TO126 and TO220 devices, just a couple really. It's mainly all TO92 stuff because I'm running out of big numbers of TO92 devices, especially high voltage stuff and good stuff to put in amplifier front ends. And I need the numbers so I can match stuff, and I need the high voltage parts because I'm building higher voltage amps. So I've just got to wait for that to come. I don't even know if I'll get these built up until those transistors arrive, because I'm not going to rush it. I want to put the right transistors in it, and I'm not going to build it twice. So I have to wait on transistors, but that's not going to stop me working in the meantime, put it that way. Anyway, back to this. So here's our bases, here's our 100 ohm base resistors. This is all what's underneath this book on breadboard. So like I said, the transistors are all MPSA 42s and MPSA 92s. The LEDs are just red, what do you call them, gallium arsenide LEDs. I've got 47 microfarad electrolytic capacitors and 5.6K resistors making up the LED references for stability and reference reasons. 680 ohm tail resistors for the current sensing. Separate current sources for the VAS and input section. Currently these are both set at 2 milliamps. Now I've got to talk about what's going on over here in a minute, but the 2 milliamps on this section, that's final. That's what I've decided upon. I've also added 500 ohm pots across these 268 ohm resistors. So I've trialed a lot of different resistor values. I'm still experimenting with these resistor values that are in circles. These two, and there was one more somewhere. Oh no, it was that one, and I finished that. Those two. Sorry, no, it's just these two that I'm still experimenting with, and obviously the negative feedback network. I still got to decide if I want a bypass cap, if I want a RNC to ground, and if I do, what the values are. Anyway, this is just set at 15K at the moment, just whilst I was working on the input stage because it's grounded at 15K. So yeah, these could get adjusted, but these I've gone down as low as 47 ohms. I found without the Wilson current mirror, it's good with about closer to 56 ohms on one side and 68 on the other. With the Wilson current mirror, it's good closer to 68 on both. Either way, a 500 ohm pot will be enough on each side to bring them into where they need to go, and the resistance will still be in between, say, 60 and 68 ohms on each one, which is fine. 56 ohms was basically 56 to 68 ohms is the sweet spot for that. So yeah, the Wilson current mirror, like I said, might be going. Now I have a problem over here. I don't know if I'm missing something, so I've still got to do a little bit more work on this circuit tomorrow. But when I'm connecting up to the rest of my amp at the moment, this VAS is just pulling this down, and I have no gain anymore. A little bit, but not much. I am not too sure yet, so like I say, I have to do some investigation. I'm not too sure if it's just something that I've got wrong in the design of this section, or I might have to make a second VAS stage. So basically there'll be one stage that's just got the diode string and some drivers, and then another stage with a VAS. I'm not too sure. Like I say, I've got to do some investigation on that too. So that's where I'm up to now, basically sorting out this VAS area, and I can't really decide upon. Actually, I will have these values decided very soon, but I can't decide. Sorry, this is decided. Just the pots have got to be set after the amps are built. So I guess I can't decide upon these component values and what's going on with the VAS until I do a little bit more work on here, and well, with these component values until the input section is actually joined to the amplifier it's going in, not just on that. So yeah, sorry, I'm starting to confuse myself. I know I'm not making too much sense. It's ridiculously late in the morning and I should be in bed, so that's what I'm going to do now. Yeah, that's all I've got really in this video to show you guys, but making progress slowly but surely. Yeah, I don't have anything else for this video, so I'm going to leave it here so as not to make the video too lengthy, and I'll be back tomorrow. Thanks for watching, everyone, and if you got any comments, leave them down below, and till next time, take care. See you soon.